In continuation with the earlier class, we started with this example, and we checked that for this example number 22, the grammar was not LL1, and the main reason behind not LL1 was the double entry in this cell. Now, I said that if we remove the left recursion from this grammar G, then what would happen? That that whether the grammar can be LL1 if we remove the left recursion, because again I am stating that there are two main part before processing a grammar was actually uh, removal of left recursion and the grammar to be left factored. So why those two parameters to be satisfied? For that reason, these two examples back to back I am showing. So the first part we are checking that here the left recursion is being present, here the int is appearing here. So for this left recursion, the two double entries or the double entries we can find it out corresponding to the D cell, right? Now once we remove the left recursion, in my last video we seen that how the left recursion can be removed using the formula. Now after removal of the left recursion, if I calculate the first of all the variables, first of A, first of D, first of D dash, and first of B. So first of A, here only B is there. First of D, here also only B is there. First of D dash, for the first of D dash, the first of capital B. The first of capital B means A. And also first of D dash means epsilon is also there, correct? So I am writing epsilon. Whether to consider epsilon in first of D dash or not, that I will tell later. So I am marking it in an arrow. Later we will discuss on it. First of B, it is simply A, correct? Now, if I try to fill the cells, if in this table, if I try to fill the cells with the respective first values, for example, here, here A is there. Now, here first of A, here we write the variable names. This is A, D, B and D. Here the terminal values B, C and A, right? Okay, just give me a time. Some noise are coming. I have to close the door. Okay, now I am continuing with my the last video. Here, the same strategy we are employing. That for capital A, first of capital A, what is the terminal? That is B. I am obtaining, right? Now, as we have obtained B by finding which production rule the B is obtained, A to BD, correct? A to BD was there, by which the first of A it is generated small b. So A to BD, that's why we have populated in this cell corresponding to A and corresponding to small b, right? Now any other terminals are there for first of A? No terminals are there. So only the single entry is there corresponding to A rows. Similarly for first of D, capital D, here only small b is there. So for small b, what was the production rule to generate this small b? To generate the small b, this was a production rule. D to B D dash. So D to B dash respectively, we put in this cell corresponding to B for the second row D. Now similarly for the next variable, that is the B, for capital B. So first of capital B is A, right? So this A is being generated from this production B to A. So that B2A right now. So that B2A is being generated over here, and we put this production rule corresponding to this cross point over this B row and the A column, right? Now for the last variable D dash, right? here d dash, the two values we can find either a or epsilon. So I said I may consider, I may not consider epsilon. There is a reason. The first of d dash, if I consider only a, then a is being generated by this production d2b c d dash, correct, from this production, because first of d dash means first of b, and first of b means this one, right? So for that means the parent production was d dash to b c d dash, from which we obtain the first of d dash as a, right? So I have to write that particular production d dash to b c d dash over here. So the same thing we have written, that to generate the variable a here corresponding to row d, the required production rule is this one. Now if I don't consider the epsilon right now, then you can check that for all the cells, the single entries are there. Correct. The same grammar I had taken here. The grammar initially had a left recursion. Once we remove the left recursion, the same grammar never generates any conflict in respective cell. So as per the table here, I can say that the grammar is LL1 now. The grammar means the production, the modified production that I have taken. But the table is not completed yet. That's why I have written here this is incomplete table, because we have to do something with this epsilon, because there are no columns are there for epsilon. Now you can check. So what to do with the epsilon? For that we need to calculate the follow of d dash. That means the variable that is generating epsilon, I have to calculate the follow of d dash. And let the follow of d dash is generating some variable, let b or c or a, correct? Corresponding to b, c and a, I have to mark an entry, some entry, some entry and some entry. If that is the case, that follow of d dash, as epsilon was there, try to uh, understand and also to remember the ideology, that as epsilon is being generated by d dash, so we are finding follow of d dash. Now if the d dash, follow of d dash contain these three variables b, c and a, we have to enter some entry over here corresponding to b. Okay, now for d dash, no? Not for b, for d dash we have to mark some entry over here, one entry over here, one entry over here, and another entry over here. Now if I put another entry over here, then again the same problem arises, that two entries are there corresponding to d dash, because already this entry was there and another entry just recently added. Then the grammar will not be LL1. That is the reason in this present scenario we cannot tell that whether the grammar is LL1 or not. This is why I said this is incomplete table. Now how to calculate follow, so that we will learn in the next video. But one thing to be clear, that to generate the predicting parsing table, you have to write the variable name in the column wise and the terminal name in the row wise. Then you have to find out the first of the non-terminals and which production is being used to generate the terminals for those non-terminals. You have to point it out and need to enter in the respective cell in the predictive parsing table. If you find double entry there, then the grammar cannot be LL1. Correct. And that decision you can take only if there are no epsilons are there. For example, if I am taking, let I have a production. Let this is a grammar. Here they have given a to small b, capital M, and let capital M generate D, and it is generating also capital N, and capital N is generating uh, T, right? For this grammar, whether the grammar is LL1 or not, we have to check. Then what we have to do, that A, M and N, for that we have to prepare a table. And what are the terminals we have? Terminals are B, D and T, correct? So B is a terminal, D is a terminal, and small t is a terminal, correct? So three terminals are here. Now we have to calculate the first of each, first of capital A, first of capital M, and first of capital N. So first of capital A, it is small b. This is very simple. You can find it out. First of capital M, it is D. First of N, it is T. Right? Now they need to write in double. They need to write inside the curly braces. Correct? When we write several parameters, we have to use the curly braces because this is a set theory notation. While multiple datas are there under a set, then we have to use the curly braces. Correct? Now if I consider the first of A, the first one, first of A is B, it is being generated by the production A to BM. So I am writing here A to capital BM. For second variable M, small d, so it is being generated by capital M to DN, capital M to DN. For T, it is directly T, so here N to T. In this table you check, there are no areas are there where epsilon is there in the first function. So if no epsilons are there, then no need to calculate the follow, right? No need to calculate. Just you can proceed, and here in this table, by checking the table that there are no double entries in the grammar and respectively predictive percent table, so the grammar will be LL1, no doubt is there, right? But if I add a twist over here, let n is generating t or n is generating epsilon, if I write n is generating t or n is generating epsilon, that means the first of n, then it will modify, it will be t and as well as epsilon. Now if there is epsilon entry is there, right, then we have to calculate the follow of capital N. There are no ways are there. Now while finding the follow of n, so in the first what we did, first we find it out the first function of all the non-terminals. Then we prepare a rudimentary or preliminary predictive percent table. If we find a epsilon move in the production rule, then corresponding to the epsilon move, the respective non-terminals follow we need to calculate. How to calculate that I will explain later. But now assume follow of that non-terminal, it contains the value, let B and D, for example. That means for capital N follow, two entries will be there corresponding to value B and D. So that means some entries will be there corresponding to B and D, and that entry actually are marked as N to epsilon, N to epsilon. That is a standard format. Because this epsilon is being generated from N for these two terminal value B and D. Right. Now still if I am obtaining, I don't know what will be the follow up N, just I am assuming and I am writing here. Don't take it that I have calculated and I am written. Now if B and D I am obtaining, then N to epsilon and D to N to epsilon, if I am obtaining this final table, then still the grammar is LL1, because there are no double entries are there in the predictive percent table. But unfortunately, if I am obtaining B, D and T, for example, three variables under follow of capital N, then definitely there will be an entry N to epsilon. This is a T actually. This is T, this is epsilon. Then there is a double entry is there. Under that condition, the grammar will be not LL1. I hope the idea is clear. First, a grammar is given. Find out the first. Then prepare a rudimentary table. Then check any epsilon is there or not. If epsilon is there, find out the follow of that non-terminal. After finding the follow, you need to put N to epsilon or that to epsilon production for the terminal being generated by that non-terminal. Right? I hope the ideas will be clear. Okay. Now I'm coming to another example. We'll be moving through different examples later. But the main idea that I have explained over here, that is very simple. Correct. Now, if I am taking one more example for you, let another production I am taking. Let if to A to small a capital B, or if I am writing A2, or this is small a small d, right? And capital B is generating uh, small m. Let this is a grammar. For this grammar, whether the grammar is LL1 or not, to check certainly whether the grammar is LL1, you have to produce the predicting parsing table. A and B, the two variables are there, right? And the terminals, A is a terminal, DA is a terminal, and M is a terminal. Three terminals are here. Now we have to calculate the first of A. So the first of A, what are the values? Only A, no options are there. First of B, first of B is small m, right? So now here, when I have to fill up the cells, so first of A means A, correct? If I am putting A for this cell, then either I may use this production, or I may use this production to generate A, correct? Because both have the small a as a terminal in the beginning. So I should write two productions over here, A to capital B, or capital A to small a and D. Because both the productions are capable to generate small a as a first of capital A. For B, this is small m, so B to M is directly there. Now you check that in this cell, two double entries are there. Two entries are there. That means the grammar cannot be LL1. That is sure. Because for a single terminal, two productions are there. The parser is being confused. That to proceed with which production? Either with this production, with this production. So the parser cannot take any conflicting situation. It takes a steady first situation. That whether I have to go with this, that means this. Whether I have to go with that means that. That is the reason if double entries are there, a conflict is being generated and parser is being confused. That's why cannot take a decision and the grammar is being rejected. Right? Okay. I hope 3-4 examples already I have given over here. That this example also, this example and previous two example, the idea should be clear. Now, the left recursion issue, actually our intention was to discuss the left recursion issue, correct? That why the grammar to be left recursive free. Now we check that once the left recursion is removed, the grammar is fine, but the table is incomplete. As you see now, that once the epsilon move was there, we had to calculate the follow of d dash, right? We had to calculate the follow of d dash because the epsilon was there. Without this follow of d dash, the table was fine. No problem was there in the table. Now it depends that what are the values are being generated in the follow of d dash. Based on that, we have to take the decision the grammar is finally LL1 or not. That means if I am finding some values, let follow of d dash is generating only B and C, then it is fine. There will be an entry over here and there will be another entry over here, two entries. So single entry, single entry, single entry. That means d dash to epsilon, d dash to epsilon. No problem, still no problem. But if unfortunately we are obtaining A also, then here there will be another production d dash to epsilon. For that, two double entries or two entries will be there in a single cell, and then we have to reject the grammar for not being LL1. Correct? Okay. Now we are moving to the next problem, that why the grammar to be left factored, right? So here you check for this grammar. Here the simply, this is very simple. You can check. The S is generating IETS and also IETS SES. The same example I have taken that I had taken earlier while explaining how a grammar can be left factored, or it is generating A and another production is there E to B. So four productions are there in a grammar. This one and this one. Now what is the first of S? First of is small I and small a as also. What is the first of E? It is B. Now I small a and it is B. Now, first of S, if I try to prepare the predictive percent table, if I am writing here, okay, so this is S and let this is E, and I'm writing all the variables over here, I, T, E, B, and A, right? This is the table, the same table I have shown. Now you see that for this table, for I, to generate A, only single production is there, S2A. So I can write S2A over here for S. For I, terminal I may either I may use this production or I may use this production to generate I, because I is in the beginning here, also I in the beginning. So that means surely you can be sure that two entries will be there, S2 small iets, one production. Another production would be S2 I capital E T S E S. So in this cell, two entries are there. So by checking that property, we can tell the grammar is not LL1. For E also we can fill the cells like E to B is there. So E to B will be there. E is not creating any problem, but for S is creating problem. Why? Because double entries are there in a cell, corresponding cell S and I, right? But once the grammar is left factored, you know how to left factor the grammar. The same grammar is there. If you have forgot the property, you should check. That is very simple. If the grammar is left factored, here the same grammar with after performing the left factoring I have written. Here, if I'm calculating the first of S, then it will be I and small e. Then first of S dash, it will be ES. Sorry, it will be E. I have to erase it, but it will be E or epsilon. Then first of S, sorry, it is first of E. It will be B, right? Now you see the conflict that I had earlier for first of S, it was two I's, but correct. Last time we had seen, no? But here only the single production is there, which is generating the small I. So the parser is not being confused. That S has two I's, two I's mean two I variables to proceed with which I variable. So for S to I TS only single entry is here. And for A, another entry is here. In the same way, for S dash, E and epsilon, correct? So S is generating E, so E is there. You can check for this S dash. For E, it is B, so E to B is there. There is no problem with the table. That means no conflict arises over here. So the grammar I can tell as of now LL1. But again I am telling the table is incomplete. Why? The same thing, because earlier I said that if there is a epsilon move is there, we need to calculate the follow of that variable. The follow of S dash to be calculated. And what are the variables are coming over here, we need to take it and need to fill some cells for S dash. Then only we can decide the grammar is LL1 or not. If this cell and this cell is populated, then it is fine. Or this cell or this cell. But if any entries come over this cell, the grammar definitely would not be LL1. Okay. Now that's why in the most of the cases you've seen that I have written the incomplete table. Because the grammar initially had the left factoring property. After performing the left factoring, the grammar is fine. Initially the grammar was not left factored, I should say rather. Once the grammar is being left factored, the problem is erased. But still the epsilon is being generated and we cannot take a steady first decision over here that whether the grammar is LL1 or not. We need to find out the follow of that non-variable or that variable non-terminal or the variable which is generating epsilon, and then we can calculate and subsequently we can tell, right? So I hope the idea is clear before you, that we started with the two principles, that the LL1 grammar, when we process some grammar through the parser, the grammar to be left factored and left recursion free. So I hope now the idea is clear. If the grammar had a left factoring, without left factoring, if I process a grammar, then there will be conflict. So it will be rejected by the parser subsequently. And the same way, if a grammar have a left recursion, then again the double entries will be there in the previous example we have seen. So this grammar also we cannot proceed. So now the question comes that what grammar we should proceed. The grammar should not contain any left recursion. The grammar should be left factored, and then we can proceed. But we cannot definitely tell the grammar will be LL1, because if any epsilon moves are there, we need to check the follow of the non-terminal. Correct. Now we will be moving to that particular property, that how to find it out, the follow of a non-terminal for a variable. Correct. Right. Now, before starting the follow of a non-terminal, three rules you have to remember. Correct. These three rules we have to apply subsequently every time when we will be using the follow function. The first is, okay, I'm taking a new page and here explaining. Let here there is A2, B, C, and small d. Correct. One. Okay. Let the writing in this way. I'm writing in a different alpha, beta, and gamma format. Alpha. This is beta and gamma. I don't know whether alpha is a terminal, beta is a non-terminal, or gamma is a terminal or non-terminal. I don't know. Alpha, beta, and gamma format I have written. Let this is a production, and some more productions are here. This is the parent production. That means the root node from where I am starting. Right. Let some production may be there, alpha to something, or it may not be, or beta to something. Let alpha and beta are non-terminals and gamma is a terminal. So alpha will have a production, beta will have a production. As per the principle number 1, the follow, I am writing follow using the F4 format. Na? Follow of the first root node. What is the root node? A will contain dollar symbol. This is the first principle. So the follow of A will only contain dollar, not follow of alpha, not follow of beta. We are not bothered about whether alpha is a terminal and beta is a non-terminal or not, because the first production rule from which I am generating the tree, because A is a root node now, from where I am generating the tree, alpha, beta, and gamma. From alpha, I am generating something. I can generate from beta, I can generate something, or I can generate even epsilon, or even I cannot generate any move. So A remains a root node. For the root node, the follow of that root node will be dollar. This is the first rule. Okay. Now the second rule. Okay. The second one, principle number 2. If I have a production in this format, A2, alpha, beta, and gamma, correct? Again, I'm writing. If we have a production that if A2, alpha, beta, and gamma in this production rule, that means if 3 segments are there, try to remember in this format, segment 1, segment 2, segment 3, right? Then the first of the third segment will be the follow of the second segment. That means follow of the second means follow of beta will be follow of beta, whatever will be there, the first of gamma will be assigned to follow of beta. I am putting an arrow over here like that. So first of the third segment means the gamma. First of the third segment, whatever the values I will get will be inserted into the follow of the second segment. The follow of second means beta. Correct? I have no doubt is there. Like let I am taking one more example that will be clear before you. Let if there is a production A2 alpha, not alpha, let alpha, beta, gamma, and delta. Then you will tell that sir, here are three segments. Here are four segments are there. Then you can assume this is one segment, this is another segment, this is another segment. So alpha, beta in one segment. So you can tell that follow of gamma, that first of delta, whatever will be there, will be assigned to follow of gamma. Because the third segment first will be assigned to the follow of the second segment. Now you may not, you want to change the production. Let if you want to write A2 alpha beta gamma delta in different format, alpha beta gamma and delta, you said that sir, I will take this one is a first segment, this was the second segment, and this third one is a third segment. For that scenario, that follow of beta will be the first of gamma delta. The idea is very simple. The first of the third segment will be the follow of the second segment. So whatever the value I will get in the first of third segment gamma delta will be assigned to the follow of the second segment. So different scenarios I have explained here. I hope you can understand, because I started with a simple example alpha, beta, and gamma, which have three different segments. If I have four variables, then I can combine it as a single segment, or even I can combine last two one as a single segment. Now you might be asking me that sir, why I cannot take middle one as a single segment? That means A2 alpha, beta, gamma, and delta. You will tell that sir, I will take it as a single segment. This was a single, this was a single. Then you will tell the follow of beta gamma first of delta. Yeah, that is true. Certainly you can do that. But what you will do by finding the follow of two variables in a single time, you check in the predictive parsing table that if a variable is generating epsilon in the first of a, let it is epsilon, then only you have to calculate the follow of a. Only for one variable you have to find out the follow, not for a joint variable, for a single variable. So here you are finding the follow of a joint variable. There is no use of it by taking this type of strategy when you have a find out a joint follow of a two variables. But certainly this architecture you can follow, this architecture you can follow, because here there is a single variable is there, follow, for which you are finding. There is also a single variable is there for which you are finding. Or even for this one also, single variable is there for which you are finding the follow. Right. So this was the second rule. Now I am coming to the third rule. Okay, I have to take one more page over here, I suppose. Okay, I'm writing over here. Okay, the third one. Third one is, let I have the same way I'm writing alpha, beta, and gamma. Rule number 3. Then alpha, beta, and gamma, if I am having, then if I can classify this alpha, beta, and gamma in two segment format. This is one segment, this is another segment. This is one segment, this is another segment. Then the follow of this part, which generating the production, will be 2 in the follow of the second segment. That means follow of A. Here again you see that first you see, then you would decide that what is happening. That if I have a production A2 alpha, beta, and gamma, if it has a two different segment, though three different segments are there, if I can make it a two different segment, then the follow up A and follow up gamma we need to follow. what is the that part? Here you see that first I am telling over here, then I will be coming to the three variable segment because it will be more clear before you. Here A is generating alpha and beta, two segment. So the follow up A, you check the follow up A will be coming inside the follow up beta. The follow up A is coming inside the follow up beta. So the second segment. That means here, if I am checking the follow up A and follow up gamma, I am considering, right? I was considering this part. So that means follow up gamma, that will be whatever I will find the follow up A. So the whatever the calculation I obtained by finding follow up A will be coming inside the follow up gamma. Now here alpha beta I have taken in a single cluster, gamma in a single cluster. Now you will tell that, sir, can I take alpha and beta gamma format? Alpha and beta gamma format means in this format, alpha in a single variable format, beta gamma in second format. So in as per your statement, then follow up A would be the follow up beta gamma. Again the same problem is there. What you will find by finding two variables follow, never it will be used. So this is an obsolete rule that you are using, correct? So alpha, beta and gamma you need to follow. Now if let there's an interesting situation is there. If there is a production A2 let beta, can you, and let I don't know whether beta is a terminal or non-terminal, can you apply the rule number 3 over here? No, three segments are there or two segments are there, you can put epsilon over here because epsilon means 1. So under that condition, follow up beta, the follow up A will be going to the follow up beta because here I can take it in a two segment format. So I can put epsilon anywhere I require if the situation arises. So in the last example, in the rule number 2, we seen that if 4 variables, 5 variables are there in the production, then how to take third segment and will be inserted to the second segment. But in the rule number 3, we have seen if only one variable it is generating on terminal or non-terminal, whatever it is like beta, then I can put epsilon in the beginning to make this one as a second segment. The follow up will be inside the follow up beta. Okay, so 3 rules again I am revisiting. The first is the follow of the parent node will contain dollar. Second, if I have a production A2 alpha beta gamma format, then the first of gamma will be the follow of beta. Then first of the third segment will comes under the follow of beta. That means second segment. And if I have a production A2 alpha beta, then the follow up second segment, follow up beta, follow up A. So follow up the second segment, when I will calculate, that will contain whatever the values are there in the follow of the parent node or the production node which it is generating. I should not say parent node, the node which is generating the production follow up. These 3 rules are there. Okay. So today, as of this part I have explained, just revisit these portions. In the next video, we'll be taking more examples and we will apply the follow, because here our intention is to calculate the follow. Applying these 3 rules, we will calculate the follow for those non-terminals which generates epsilon, correct? Because you've seen now that here epsilon was being generated it by s dash. So we have to find out the follow up s dash, I said last time. Now how to find out the follow up s dash? Those 3 rules to be applied, and we will be looking through the example subsequently in the next video.